So without any further ado, I would like to introduce Simon from Semiotic Labs, and we will get started.
Thank you very much. My name is Simon Jagers. I'm indeed one of the founders of Semiotic Labs. And at Semiotic Labs, we've developed a monitoring tool for industrial electric motors and rotating equipment, such as pumps. And they're, most often very critical components in one of the most critical systems in our daily lives, right? So the water and wastewater treatment. And our clients use this tool to improve the reliability of their systems and to address several challenges in their day-to-day operations. So today I'd like to share our story. Now, if you like what you see, then I urge you to reach out to me because we're looking for partners across the globe to make the water industry better, safer, and more sustainable. But let's start with, the issue that we solve. And I think you can summarize it in the fact that water and wastewater infrastructure management is flying blind to a large extent. When you look at what's going on today, as mentioned, water, wastewater, some of the most essential services in today's society. Electric pumps or electric motors and pumps are the most critical components in their operations. So keeping them in good shape is essential. However, 5 to 15%, depending on where you are on the application and so on, will fail each year. And most companies really are flying blind because they don't have condition information and because their assets operate in large areas, which is difficult to manage, right? So as a result, we see some very inefficient and wasteful maintenance practices and strategies being deployed. Think of preventive maintenance, where the basic strategy is to perform maintenance too soon in order not to be too late. So it's not based on the condition, but purely on the age. We see a lot of corrective maintenance where those assets have failed unexpectedly with outages as a result. And I think today this is simply no longer sustainable as a practice because communities are at risk when your water system or your wastewater system fails. And to add injury to insult, what we're observing is this increasing skills gap where maintenance technicians are retiring in record numbers. And this truly is one of the biggest challenges in this field. 1 in 3 will retire in the next 5 years. And because young people nowadays, they want to learn how to code an iPhone app and not learn how to fix a broken pump, the obvious issue is that those iPhone apps won't fix your water system. So what we're looking for is more efficiency. And on top of that, what we also observe is that unsustainable practices are no longer acceptable. So what we're also looking for is systems to help give us data-driven insights into how we can make our systems more reliable and more sustainable. And the solution to many of those problems simply is that information, is that insight. So information in the form of an alert when something is about to fail, information in the form of an insight into the condition of your overall asset base so you can effectively manage that, and information that tells you where you can save energy, knowing that about 10% of global electricity is used by pumps, right? And so our solution, what a SAM4 is a comprehensive monitoring system that consists of sensors, analytics, and a dashboard. That system will monitor your pumps 24/7 to detect developing issues at an early stage so you can act based on data-driven insights into the performance, the health, and the energy consumption of your systems. Now, fairly simple to set up. We install inside the motor control cabinet where we start to generate data. The data is sent to a platform where we start a learning phase. And once that learning phase, typically lasting 2 to 6 weeks, has been complete, we go live and we will provide you the insights that you need to effectively manage your infrastructure. Now, obviously, it's all about usability, right? So we present it in a very clear dashboard that gives you the insights needed. So then next question is, how do you use this in your day-to-day operations? I think a frequently observed use case is simply preventing unplanned downtime. So what we do about is we monitor your systems. We will detect things like cavitation, dry running, bearing failures at a very early stage, at least a couple of weeks, but up to 5 months in advance. And we will give you both a visual indicator of severity as well as some deeper analysis as to what the underlying cause is. And our clients, particularly asset owners, use this to schedule inspections, repairs, or replacements well before their assets fail. Now, I also mentioned that this increasing skills gap, or this widening skills gap, I should say, is a very big issue. So it's about optimizing your maintenance resource allocation. So if you have an insight as to what the condition and the performance of your overall asset base is, this will effectively help you to manage your availability at the best possible cost, effectively reducing unplanned downtime, but also allocating those maintenance resources in line with the most important question: does this asset need attention, yes or no? Now, a third way that we help our clients is by reducing energy waste. Again, more sustainability is something that is very useful nowadays, obviously. And what we effectively do is we provide you with insights into the efficiency of your assets, but also a tool like the real-time pump performance curve that provides you with where your pump operates relative to its best efficiency point. And as an example, one of our clients used this to save 90,000 euros in energy cost, or the equivalent of 27 households, on just 3 pumps. And we often observe this effect. It's around practicality, it's around data-driven insights that help you to not only increase availability, but also reduce energy waste. Now, most of these type of systems that we observe in the marketplace are based on vibration. But what we actually do is we use motor current signature analysis. And what that means is that we analyze electrical waveforms. And that has a couple of benefits. I think first and foremost, from a maintenance perspective, it simply has a much higher detection rate. So your pump will fail due to mechanical or electrical failures. Both can happen. Traditional systems detect those mechanical failures. We do both, right? So we simply detect around 3 to 4 times more failure, or we have 3 to 4 times less failure incidents than comparable systems. So that's valuable in and of itself. But it's also easier to scale, particularly in the water industry, where you have things like submerged pumps or pumps operating in very harsh conditions. We install inside the motor control cabinet, which makes it easier to install in large numbers, and certainly helps you to monitor those pumps that are submerged or that operate in very harsh conditions, because you don't have to install anything on the asset in the field. And the third benefit over alternative solutions are those valuable insights. So it's not just about monitoring of the condition and the health. It's about optimizing the use of your system based on an individual asset, but also based on how the system acts as a whole. And this type of information is very useful in that regard. Now, SEM4 is offered as a subscription service. So typically, our clients buy the hardware and we provide the monitoring service based on an annual subscription fee. So the data is analyzed by Semiotic Labs algorithms, so there's no need to train your own people in analyzing electrical waveforms. We provide that for you. We'll also provide you with additional insights through our maintenance engineering team, and the algorithms just keep on learning, extracting more and more value from the data, and that's all part of that subscription that's improving on a day-to-day basis. Typical fees are around $600 to $800 per year. For very large systems, it can be somewhat higher, just to give you an idea of what you should think about. Now, before I go to my last slide, quick introduction of the company. If you like what you've seen so far, as mentioned, we're based in the Netherlands. We use AI to eliminate unplanned downtime, reduce energy waste, and make the water industry better, safer, and more sustainable. And we do that by working with partners. So if you're an asset owner, we can help you with comprehensive asset monitoring services. If you're an original equipment manufacturer such as Xylem, we can offer you technology to make your pumps smarter right out of the box. And if you're active in the field of maintenance service providers such as Engie, we can help you to deliver performance-based services right out of the box. So my name was Simon Jagers, as mentioned before. This is my email. This is our website. If you like what you see, please do reach out, because I truly believe that together we can make the water industry better, safer, and more sustainable. Thank you very much.
Simon, first of all, that was a great presentation, and you're going to get my vote for the most improved from 2 days ago. You're right up there. Congratulations. That was you really hit all the points. So thank you very much, and also for staying on time. Okay, we're going to move. No, it was great presentation. So Magali, we are going to move over to you in marine tech in southern France.
So thank you, Michael, and all TMA BlueTech team to give us the opportunity to present our water solutions. To present the first one, I will take you under the sea to talk to you about how we catch fresh water from the sea, and the second one, how to produce drinking water thanks to solar energy. Our company, MarineTech, is an innovative company created in 2014 and based in south of France. We develop our activities in the field of marine environment and water. And I'm going to talk to you today about two solutions of sustainable production of fresh water. All MarineTech's activities are part of the sustainable development and blue economy. We are a young company, but with a strong experience of the managing team of more than 15 years of marine works and projects in France and abroad. Let me take you under the sea to talk about submarine springs. A submarine spring is an old on-land spring that has been immersed by the sea over the time. Also named aquifers, they are the result of a combination of several processes during the ice ages, variation of sea level and exposition to precipitation which infiltrated in depth. Much of the water under the seabed dates back to glaciations between 5 and 2 million years ago. In every ocean, every seas, this phenomenon exists. This resource is huge, estimated to 500,000 cubic kilometers, a resource that could be exploited by countries where water is scarce. Here are on these pictures some examples of impact of freshwater submarine spring on the sea surface, a spectacular submarine spring offshore Latakia in Syria in the Mediterranean Sea, and below the spring of Heraklion in Greece, and the spring of Koyat in Oman in the Arabian Sea. Since 1999, we have set up a methodology to explore the seas and to locate precisely those springs. This is the exploration phase of the area of interest, and we have designed and engineered a special device to catch the flow of water from the springs that is installed during the production phase of the springs. Here are some results of the exploration phase. We carry out geological studies, meteorological monitoring, and satellite studies to evaluate anomalies in the area of interest. After the location of anomalies, thanks to aerial survey, with thermal camera and marine survey carried out with marine drones, with oceanographic sensors like sonar, current meters, salinity probe of area defined with the clients, existing springs can be precisely located. And then they are equipped with special devices for being monitored. Flow, salinity, temperature, and chemical parameters are monitored during several months, during several seasons, to assess the quality and production capacities of the springs and to size MarineTech tapping unit named the Tulip. This tapping unit has been specifically designed to respect the spring. It collects only the flow of fresh water naturally produced by the spring, without pumping, without fuel, without electricity, and without any other energy input, preserving the water balance resource. This technology respects the environment and humankind. Our production units are installed as close as possible to the sea bottom to leave navigation free from obstacles. Production costs are optimized, and this water can be used for agriculture, industry, and drinking water. After this dive under the sea, let me bring you back to dry land to talk to you about Helio, the world's first solution, 100% self-sufficient to produce drinking water, labeled Solar Impulse Efficient Solution. Still today, 1/3 of the world's population do not have access to drinking water. 2.6 million people per year die from water-related disease, and children are the first victims. Helio is a 100% self-sufficient equipment using solar energy only. Helio purifies or desalinates any type of water unfit for human consumption. Seawater, brackish water, water from rivers, from ground, etc. to make it drinkable. Helio is simple, affordable, flexible, and sustainable. It is dedicated to population living in remote and arid areas where there is no conventional water facilities or defective because too complex, with no technical skills and limited financial means. Helio works everywhere the sun and water source is available. Helio is cost-effective, fast, and simple to install, to operate, requiring no maintenance, robust and sustainable with a 30 years lifetime. How it works? Helio is inspired by nature. It works according to a process that the Earth invented more than 4 billion years ago, the solar distillation. Thanks to a pump powered by a solar panel, water to be treated enters into heliosphere, where it is heated, turned into vapor, which then condenses on contact with the wall of the sphere. This distilled water is collected at the bottom of the sphere, then remineralized by Helio to make it drinkable. One module produces up to 10 liters per day. This is drinking water for a family of 5. And as solar farms, several Helio modules can be installed together to produce drinking water according to the local need. It is eco-design, its elements are 100% recyclable, it has very low operating costs, and it is scalable by adding new modules if the need evolves over the time. It avoids greenhouse gases emission, plastic waste, and chemical pollution. Our manufacturing facilities are based in France. These facilities have been co-financed by the European Union and the South region. It has a production capacity of 1,000 modules per year. First sales started in 2020 with first farms installed in Polynesia and in Oman. And our clients for both solutions, submarine springs and Helio solutions, are typically public authorities such as Ministry of Water or municipality or public service delegation in charge of water production and distribution. The second type of clients are NGOs, foundations, sponsors, etc., wishing to help population in need. We carry out a water project for Suez, General Water Authority of Libya, Central Water Authority of Mauritius, and the state of Qatar and Suez, and any other clients. Our ask today, we want to develop partnership to approach new markets to propose our solution for sustainable water production. And we are looking for distributors, business providers, investors, and meeting with customers or companies for water project collaboration and synergies. So I am Magali from Marine Tech, and here are my mobile phone and my email address, and you can follow us on the social media. And thank you for your attention, and thank you for your next question.
Magali, thank you. That was a wonderful presentation, and you and Simon both get high votes for having really refined your pitches. Well done. I just want to mention a couple of people that are in the audience. I don't know all of them, obviously, but we have Fanny from Polymer Méditerranée, and of course, Marine Tech is one of their member companies. They're one of our partners. We have representatives from the DG MARE European Commission in Brussels, one of the leading accelerators in Portugal, gentlemen looking for disruptive technologies, the World Bank, a representative of the National Oceanography Center in the United Kingdom. So we've got a pretty impressive group of attendees. So I just want to point out that these are people all looking for innovation, and these are two great companies doing innovation. So you've kept us very much on time. So the third presenter will be Oriana Bretschker, the president of Aquacycl. And after that, Haro, I'm going to leave it up to you to manage the question and answer period. So Oriana, you're up.
Thank you. I am sharing my screen. Are you able to see?
We do.
All right, great. Terrific. Well, thanks very much for the opportunity to speak today. My name is Oriana Bretschker. I'm the founder and CEO of Aquacycl. Aquacycl is headquartered in San Diego, California, and our goal is to treat ultra high strength wastewaters. And so specifically, we're trying to address these major issues that arise within food and beverage production facilities. So what we call ultra high strength wastewaters are actually about 100 times to 1,000 times more concentrated in organic carbon or chemical oxygen demand than what you see in a typical city sewer. Most food and beverage manufacturing companies will require that these wastewaters are hauled off-site and land applied, or if they are in a municipality that allows them or permits them to discharge to sewer, they have to pay by pound of chemical oxygen demand or pound of total suspended solid, TSS. And this can be very costly. A single facility may actually pay $1 million to $2 million per year just to manage these.
Oriana,
yes?
I'm sorry, something happened and your slides are not being presented. So I think you have to just reshare. So I think you might have clicked off of it. So sorry.
Okay. Perfect. That's better. All right. Okay. Everybody seeing it?
Yes.
Yes.
Great. So the cost associated with managing these wastewaters, right, is huge. So it could be per facility $1 million to $2 million a year. And if you're operating 500 facilities globally, these costs add up significantly. And of course, you know, land application is not a sustainable solution. And we'd love to be able to enable water reuse on site. And so that's where our technology comes into play. We provide a plug and play on-site treatment unit, which can typically save our customers anywhere from 20 to 60% against what they're paying now, whether that's a hauling cost or discharging to a sewer. We have demonstrated and validated the technology with companies such as Anheuser-Busch as well as Mars Wrigley, and we just closed a master service agreement with a large global food and beverage producer as well. So we'll be installing a system for them at the beginning of 21. And through these demonstrations that we've done with our commercial partners, we've validated that the system can work quite well in dynamic production environments. So we can handle those production shutdowns over the holidays. We can handle a product switchover if it's required that they're changing a brand. And because we are actually monitoring these performance real time and remotely, we can catch any potential problems before they become issues in terms of treatment quality. And so this real time operation and real time monitoring and control also limits the the physical presence of operators on site with a facility, and especially in these COVID times, that can be very beneficial. And so this is what a client will see on site, literally how the technology works inside that little black box that you see on the screen. What that is a bioelectrochemical treatment technology, and we use naturally existing bacteria already present in the wastewater. And what we do is we'll bring those bacteria into the reactor, and they start to form biofilms or fixed films on the surfaces inside of each reactor. And so those bacteria will sit on those little vertical cylinders that you see there on the breakout, and they start to use those cylinders as a way to breathe or way to respire. And in that respiration process, those bacteria give up electrons. We capture those electrons, we move them across the circuit, producing DC power. We actually generate enough power to offset the energy demand of our systems. That can be net neutral. In some cases, we can be net positive depending on what we're treating. But the relationship between electricity production and treatment rate is really the coolest part of this technology. So the more electrical current that we draw, the faster we're moving those electrons away from those bacteria, the faster we're making them breathe. And when they're breathing fast, that means they're eating fast. So the more electricity that we produce actually means a faster treatment rate. And so what we do is we take these little black boxes, which are all about the size of a standard car battery, and we stack them together like Legos inside standard size shipping containers, which can plug and play anywhere in the world. And the example that you see in the circle there, that's a system that we built for a small brewery outside of Joshua Tree National Park here in Southern California. And so here's some examples of some additional equipment that we've installed with our commercial partners. We do have manufacturing now already established in South Korea and Tijuana. We're moving into a new production facility this month here outside of San Diego, so we can scale and meet our customer needs more quickly. And so just to give you some examples of performance here and the types of wastewaters that we treat. So we're addressing these ultra high strength wastewaters. And one of the demonstrations we did with a commercial confectioner, we brought in a unit. It's a very small unit. We're processing just under a cubic meter a day. And the physical footprint of that demonstration unit is about the size of a Fiat. And so we will plug and play on the customer site. And then we'll operate this unit. In this case, it was over a 6-month operational period. And in some cases, what we're doing is actually removing up to 50,000 milligrams per liter of organic carbon in that footprint in a 4-hour hydraulic residence time. Now that number, that 50,000 parts per million or milligrams per liter, is more than what you would typically feed to a conventional biological system, whether it's aerobic or anaerobic. And so we're able to remove that in a very short period. In the same period of time, we're also generating electricity. In fact, 1.6 kilowatt hours per kilogram of carbon that we're removing in that period, which is about 25% higher than a conventional anaerobic digester. And this little Fiat was actually producing about 22 kilowatt hours in a day, which offset 50% of the energy demand of the run. And so we also produce far less sludge than a typical biological system. Only about 1% of the organic that comes to us is converted into secondary biomass, which has to be hauled away. And we can handle very high total suspended solids as well, up to 35,000 milligrams per liter. And we actually break down those solids into the fundamental components, CO2, electrons, and protons. And so this is just to show examples of how we would stack up at scale. Now, because we are essentially taking advantage of the Lego effect, right? As we scale, we add more reactors, but the reactors maintain the same size, and so we maintain the same efficiencies. And therefore, as we get larger, right, we don't decrease in efficiency. We actually multiply that efficiency, and so it's a very scalable and highly efficient product to address these ultra high strength waste streams in a very small footprint. So just giving you some examples here of a standard application. We're offering some of the fastest treatment times on the market. some of the lowest sludge production that's available, and energy recovery that is actually meaningful, and that's as DC power, right? We're not making any biogas, we're not making any methane, so that also decreases the amount of equipment that has to be installed and maintained in site. And so, you know, we are a US-based company. We're focusing on the US market, but our customers are global. And so we're very excited to be able to scale, you know, to serve that global market within the next couple of years. And really the core that we're focusing the technology on right now is in food and beverage manufacturing, specifically those high sugar waste streams. So confection, sugar refining, soda production, juices, snack foods, etc. So that's really where we've got the closest fit and can provide the highest value proposition right now to our customers. But we can also apply into other markets and have demonstrated the technology both in agricultural as well as municipal applications. And so we are also raising money. We are an early stage company, and so we're always raising money. If anybody's interested in learning more about our open round, please do contact me. My email address is listed there. And as we do grow to serve this global market, we are seeking partnerships within the EU and elsewhere because we are remotely monitoring and controlling, and our systems don't require full-time operators. We're always looking to work with companies that can provide that on-site service support in case of emergency or grabbing samples. And so we're looking for folks to contract there. We're always looking for folks that are interested in working with us in terms of opening up new sales channels and local manufacturing as we start to progress outside of the United States. So I'm happy to talk to anybody who may have some ultra high strength wastewater needs and or interested in discussing any of these other opportunities. So thank you so much, and happy to answer any questions.
Thank you very much, Oriana. I don't see any questions coming in yet, but I will ask people to urge to do so in the chat box. Maybe I can start with you and ask you a few questions about Aquacycl. The range on TSS, for example, is quite broad and quite astonishing what you can handle. So do I presume right that no pre-treatment and probably also no post-treatment is required for Aquacycl?
So the pre-treatment and post-treatment will depend on what we're starting with. So if we're working with a waste stream that has a high fats, oils, and grease concentration, for example, above 300 milligrams per liter, will require a dissolved air flotation as pre-treatment. Mm-hmm. In terms of post-treatment, it really will depend on what the use case is going to look like. So what do you want to use that water for? So if we're starting with a waste stream that has 300,000 milligrams per liter COD in it, and we're removing 90% of that COD, there's still a lot of COD left. And so in the discharge from our system. So that will require us working with partner technologies to take that down even further to enable water reuse on site for zero liquid discharge applications, as an example. We get it to a point where it can discharge to sewer, staying within sewer compliance, eliminating hauling, and reducing any of the energy demand, operational demand, maintenance demand for those post-treatment systems that work on the back end of us.
Yes, of course, you're right. A post-treatment is required with a COD of 30,000 ppm. I guess some people will ask you, like, well, but what about those food and beverage companies or beverage companies that already have an existing treatment? So, I mean, it could be a benefit. So they have for what's coming out of Aquacycl, they have a train. But how do you see that? Do you integrate, or how are your customers responding to that?
We do, because we're plug and play, right? We're not digging any holes in the ground. It's not permanent infrastructure. We need tie-ins and electrical, support, but it's not massive infrastructure changes. And so in that case, and when a customer already has an existing anaerobic digester or an existing activated sludge, as an example, we actually will work as industrial pretreatment. And so we can help level out the variability from food and beverage production stream. So anything that's feeding into their existing system which is much more normalized and predictable. And then we're also knocking down the COD so that the operational cost, especially from an energy consumption perspective on activated sludge, is significantly reduced, and the overall sludge production will be significantly reduced. Most of these ultra high strength waste streams that we're dealing with can't go into an existing system. They're hauled offsite. If we're starting with 300,000 parts per million, for example, that stream is already separated and that's being hauled. And so we'll make sure that that stream doesn't have to be land applied. And then the discharge from our system goes into their existing activated sludge, which is treating different parts of wastewater from the plant.
One additional question, a little bit on the technical side that came to my mind is what happens to nitrogen, phosphate, potassium, the nutrients which are a part of wastewater treatment, right?
Yeah. So that's a great question. Thank you. The nitrogen cycle, it was an anaerobic system. And so any nitrate and nitrite that would come to us is converted to ammonium and leaves our system as fully ammonium, which will stay dissolved as long as the pH is neutral. We'll remove about 30% of total nitrogen, but also because it's an anaerobic system, we don't do anything with phosphorus. So phosphorus in is phosphorus out, and same with potassium. We can handle very high total dissolved solids in terms of concentration. We've treated up to seawater concentrations of salts, but we don't remove them. So again, for any reuse case, we're going to require post-treatment technologies to address the nutrient loading and TDS.
The main driver, of course, for your customers is the cost driver for, and it's not the reuse of, for example, a water or another nutrient. Yes. Okay. I think in the past, microbial fuel cells were quite big out there. Also, big news. And so what has happened and what have you done to revive and bring this further so far?
Yeah. We're definitely not the first company to commercialize microbial fuel cells, but we're the first company to really make it work. So what has happened is again, that modularity and maintaining the efficiencies of the system. So instead of scaling our electrodes and scaling our reactors to accommodate larger volumes in a single system, what we did is we kept the systems very small, and we just figured out how to make them very cheap and multiply. And so because of the size of the system, it's an electrochemical system. And as you said in our earlier statements, right, we have to keep in mind the biology, the physics, the electrochemistry, the chemistry, all of these reactions that are taking place in the reactor, and size really does matter. And smaller is better from an efficiency perspective. And so that's the track that we have followed, which is just making a very cost-effective, replicable reactor style that maintains those efficiencies at the high rate that, actually higher than what we see in the laboratory.
Great, thanks. A little bit about business, also outside of the US. Do you see your primary route and strategy to go along with your, for example, US-based international beverage companies, that they approach you for a case, well, be it Asia or Europe? Or do you actively look for channeling partners in those areas as well?
We will do both.
Okay.
Some of our existing corporate clients, have talked to us about opportunities outside of the U.S. But in order to really provide a strong value proposition in other geographies, we need channel partners to help us distribute, to do in-country manufacturing to keep the cost of goods lower, and then also providing that operational service. So we will not ever be able to do this ourselves, and that's not the goal, is to scale to that, global Suez or Veolia style, wastewater treatment company, but to work with our global partners in scale.
And support them with their monitoring system. That's part of the package, which I understood. Thank you very much, Oriana. Well, and then if I talk monitoring, I'll make the bridge to Simon, as we say in Dutch, or Simon in proper American, Simon. Simon, you mentioned that SEM4 is available for pumps, water industry. Do you also monitor other types of assets or in other industries, like, for example, the maritime sector?
Absolutely. Yeah. I mean, when you look at rotating equipment and electric motors, they truly are the workhorses of the modern economy, right? I mean, around 30 to 35% of the global electricity is consumed by these machines that make anything from car tires to water go round and so on. And our system is specifically designed to detect upcoming failures in those systems at an early stage, as well as optimize their energy use and so on. Really part of that sort of that digital transformation in the maintenance domain that is also increasingly being used to, to make a more sustainable industry. And those assets operate around the globe. So we're currently active on 4 continents in industries such as the petrochemical industry, food production, steel industry, basically any industry where a downtime incident is both costly, introduces risks and so on. That's where we are at home. You're
based in the Netherlands, right? How do you seek to roll out internationally, and how do you provide support across the globe, for example, in the States?
Well, we see ourselves first and foremost as the data science nerds, if you will, and I say that very fondly. We're very good at processing data, and we can monitor across the globe. But what we're increasingly seeing that our clients want boots on the ground. So we have a partnership with Xylem, for instance. They help us out in the US. They help us out in Asia and Europe as well. Schneider Electric are a partner of ours. You can purchase SEM4 through them. They have global, support staff. They can do a follow the sun support principle. They can support it both, online, on telephone and in person. And obviously, we're relying on our partners to deliver that on a global scale. Yeah.
And they can also take over that hardware part of your delivery, I guess, Simon, and you can focus on the on the monitoring service, which is the key of the service delivery that you're providing. Is that correct?
Yeah. Absolutely. I mean, when you look at, from our perspective, the raw material of the service that we provide is data, right? So that's one of the reasons why we've built our own sensor system, because specifically for condition monitoring purposes, you need high frequency, high resolution data. I'm getting an echo. Is that me? Okay, it's gone now. So sorry. We need that specific type of data. We've built our own sensor system to do that. But the way I see it is, what we're seeing is that there's increases in sensor quality, data communication are getting better. There's simply more data to go around, and incidentally, data is a bit like love. The more you share it, the more valuable it becomes. So what I'm seeing as a trend is that data is being generated, it's being shared, it's being put to good use. But if you do it safely, everybody profits. And then we can focus on our core business, which is analytics. But that's probably a couple of years, 10 years out from now. So until then, we're very happy with our own integrated systems of sensors, analytics, and a dashboard.
Clear. Got a question in the box, Simon. Can you explain the benefit you bring to Xylem, and could others benefit? So what made Xylem decide to integrate the Semiotic Labs package?
Well, I mean, the work that we do, and specifically for pumps, is that we analyze electrical waveforms, right? Like most of these condition monitoring systems are aimed at increasing availability, reliability, de-risk. You can think of anything that makes a product more valuable when you have a better grasp of its condition. And all of these alternative systems are based on data that's being generated by a sensor. Data is being analyzed by an algorithm, a specialist, or both, and then presented in a user interface. We're just like that, except for what's unique about us is we analyze electrical waveforms. And incidentally, that's the only type of sensor that you don't need to install close to or on the asset in the field, which is very useful for submerged pumps, for pumps that operate in very harsh conditions, and so on. But it's also very much a niche product. So what the value that we bring to Xylem is that we can deliver them a product that's been proven across a wide variety of industries, geographies, and so on, and to instantly make or allow them to deliver a smart pump, a pump that calls it, that says I'm not healthy, please fix me, right? So those, and for most OEMs, or certainly for the OEMs that have a combination of an AC induction motor or an AC electrical motor powering a piece of rotating equipment, we can, in both brownfield and greenfield applications, install it in about 15, 20, 30 minutes per asset and make it smart within a matter of weeks after the learning cycle. And that's the value we bring to Xylem, and that's the value we'd be happy to bring to other OEMs in this field as well.
Thanks. We get a question, if you can, well, how you see it, the technology can exist also in developing countries, or do you see a role, for example, on countries which are lacking infrastructure or remote, for example? Do you see additional benefit?
Absolutely, yes. So what's striking, for instance, that in less developed countries, mobile seems to be faster growing than in some developing countries. And whenever we have a mobile signal, that's when we can do our job, because we need that connection to the cloud. I think specifically in developing countries, it makes a lot of sense to work more efficiently and to be mindful of how you allocate resource in these resource constrained environments. And that's really one of the core things that we do, is to make sure that you don't waste valuable resources on otherwise healthy assets. So absolutely, and we are in fact exploring those. We're doing some work in Africa. We're exploring some other areas where it simply makes a lot of sense to focus your resources on those assets in need of help.
I guess so that, yeah, in developing countries you jump immediately to a higher also IT type of infrastructure, making use, for example, of SEM4. That's actually a thought I also had for Magali. If I make that jump to you, Magali, for example, the Helio, have you considered, or it can also be the spring, the submarine spring. Have you considered, for example, also to deliver, install, and maintain, finance these kinds of solutions, for example, in developing countries where people do already sometimes have a mobile phone, which, for example, they pay for their groundwater, and that kind of models, is that something that you have considered in the developing countries?
No, in fact, at this stage, we consider a selling mode, and as an option, we propose installation and training of people and assistants. With Helio, we want make people autonomous, self-sufficient in their capacity to produce drinking water. We don't want they depend on our company. We want to make them self-sufficient.
Mm-hmm. Yes, I understand, but my question was also a little bit towards if, for example, in also remote areas where people don't have access to large infrastructure or drinking water just from the pipe.
Yes.
I can guess sometimes the financing is also the issue, right?
Yes.
So you now have a solution to provide them with clean drinking water for a family, but then very probably most of them will have a difficult time to pay for the cost of a Helio. So I guess for you also it would be interesting to have, for example, NGOs or foreign aid organizations, buying your equipment, putting it in place, and finding some kind of financial model to pay back by local users of the drinking water.
Yes, probably. This is Helio is a young solution in the market, and this is one of our targets, to go and to discuss with NGOs and foundations to better understand how they want to work with this kind of solution, if they want to purchase and to manage helio farms themselves, or if they want to do like you mentioned.
Is the water after helio drinkable immediately?
Yes, of course.
Okay. And I guess the bleed coming from such a system is usually put back. Or what is done with the bleed? Let me ask it like that.
In fact, there is no collection of waste into helio. This is not like if there a membrane that collect the residues. The system is open between the seawater or the hole where the water to be treated is collected. It is completely open between helio system and the source of water. So when there is sediment or brines, they naturally go back to where they come, in fact.
Okay. Please correct me if I'm wrong, but I see helio a little bit more as a fixed product with a design capacity, where what I hear from you for the submarine springs, it's much more a project type of approach, because
Yes.
much more pre-work is needed. And
Yes.
one of the questions coming in the chat box is how widespread are subterranean springs? So maybe you can answer that, and then also go into a little bit, where you have seen, if so, most springs being in the world, creating an opportunity for you.
I'm not sure to well understand what you mean by a widespread of a submarine spring, but we don't know exactly their widespread. We know that they are all over the world, where the geology allows their creation. So I don't know exactly their widespread, but every spring is different in terms of flow, in terms of salinity, and physical and chemical parameters. It depends on the size of the aquifers, on the meteorology of the mountain that collect the fresh water that flow under the sea. So every spring is different, in fact.
I think I've noticed submarine springs myself, and then you're swimming and you feel this cold shock coming in.
Yes.
You're swimming in nice 25 degrees water, and
Yes, and the water is troubled.
Yes.
And you had a second question, I think, no?
If you have an overview, so I guess the satellite analysis, so your pre-work before you can make an offer for the hardware is quite a bit of geoengineering, if I may call it that. I guess it's satellite imaging. You probably need to go under the sea, subsurface, to do investigations before you can make an offer.
No, investigation, exploration phase are part of our offers. We discussed before with the clients to define where their need is in matter of fresh water. We can do a preliminary geological study to know more about the geology, if it's favorable to the existing of submarine springs, of this geological process of creation of aquifers. And if it is the case, if it is yes, we discuss with them about the area of their area of interest. We define with them, and on this basis, according to the size of the surface they want to study, we will propose our offer. So the offer includes the exploration phase, because it takes several months, because we need to explore sometimes 1,000 kilometers, square kilometers. So it's huge survey and huge study to achieve to detect potential springs. So exploration is part of our offer, and when we have located precisely the springs, after studies, exploration phase, we carry out the production phase by the installation of our tapping units.
One of the questions coming in, Magali, is do you have patents and an IP protection in place for both technologies? Is that taken care of on your side, on the business side?
Yes, there are several patents on both technologies, yes, Helio and submarine springs, yes.
Browsing through the question. Yeah, so one question for Helio still comes if you would think that it's primarily effective in locations near the equator.
Yes, of course. Yes, of course. Of course, Helio, the production capacity depends on the sun radiation that arrive on Helio, but Helio is effective everywhere the sun and water source are available. So even in temperate zone, as we are in south of France, Helio works in very good way.
Clear. So yeah, one from Melissa. Do desal plants use the knowledge of water springs to choose the location of their plant?
Generally, desalination companies do not think about submarine springs. One time it happens, and we carried out an exploration phase in the Arabian Sea in Oman. On my presentation, you had a picture of this spring. We carried out an exploration phase to use. The purpose of this exploration was to use this fresh water in the process of reverse osmosis to reduce energy consumption, because, as you probably know, the cost of the cubic meter of fresh water produced by desalination, reverse osmosis, highly depends on the cost of energy. So when the salinity is lower in the process, it will reduce the energy you need to desalinate this water.
Yes. Going through a little bit, yeah, I think we have answered most questions in the chat. I was thinking a little bit when we were closing slowly to the end of the session today, if we can make a combination of all the technologies here on board today, but I have a hard time making that work, Michael, to be honest.
Well, maybe we can ask a different question. I think one of the things that you three show is the breadth of this wastewater industry. I mean, you're three incredibly innovative companies doing very different things. But at the end of our practice session on Tuesday, I know, Simone, you had to run, but Oriana, you made the comment that you'd like to talk with Semiotic Labs. I guess one of the part of the core for us, and I think for you as well, Haro, and Water Alliance, and hopefully all clusters, is that we live for our companies. We're really here to try and help them find collaboration and partnerships. And so when you hear each other, you say, gosh, there's something I think I could introduce you to. Are there ways you think you could work together? And Oriana, not to put you on the spot, you made the comment on Tuesday, I'd like to talk to you, Simone, and he'd already left the call. Do you feel like there's a way that you could help him or introduce him to anyone?
Well, I wanted to use his technology in our system. So, for all of us that are working in terms of, remote monitoring, remote controls, on inline sensors, being able to understand the health lifetime of our equipment is super critical because we don't have a full-time operator there. And our pumps are not running 24/7. So we've got a variable drive, system that goes on. We operate with very low power pumps and they're pretty inexpensive, but we still want to know when they're going to fail before they fail. And so that integration is really important.
Boy, have I got an offer for you. I think your point is spot on. You may have low cost pumps, right? But it's not about the cost of the pump when you buy them. It's about the value that they bring as a system. And in that sense, I think I'm amazed by both of what you do. I think from my perspective, what I enjoyed most about both the session on Tuesday and today and hearing about these other innovators is, from my perspective, technology should take away the age-old trade-off, right? You've all heard a version of you can make a good product, make it cheap, but it's going to be unsustainable. Pick two, right? So you can make it good, fast, cheap, and so on. I think technology has it in it to say, I want a good quality product. I want to make it at an acceptable price, and it must be sustainable as well. And I got a lot of sense that all of us are working towards that goal. And I think that's, I think that's really what makes this a beautiful place to share our story. So thank you for that.
Well said.
I'll let you guys follow up later, and we are coming up to the witching hour. I just want to say that all three of you are amazing companies and winners. Magali, I want to do a shout out. I'd never heard of anybody using subterranean or underwater springs. And what I loved about that story was that the way you went about it, the study in advance to make sure that you did not damage that spring, that you were only taking the amount of water that could be sustainably utilized. And that required a thought process from the very beginning of sustainability. And my concern is, and that's why I asked the question about the IP, I hope you have incredibly strong IP. And I hope that other people who would not come at it with the same sustainability goals that you put on it, that might essentially restrict that water flow or try and pull out too much water, would damage what could be a million-year-old subterranean tunnel from a mountains 200 miles away. And I just think that the way you've approached this is also something that we need to applaud. So all three of you are winning companies. I hope that you find ways to work together. I think, Haro, working with the Water Alliance, this is what we, from my point of view, should be doing. So to all of you that are listening, to our partners, Water Alliance and the other clusters that were on the phone, I know one of our Canadian clusters was on and French cluster. We appreciate you being involved with us. We hope that you will join us for our next, if you think it is applicable, for our next BlueTech Global Connect in October on aquaculture biomarine. Then probably in January will be plastics, but it'll be broader than that. It will really be ocean cleanup in a broader sense. And then please join us for BlueTech Week. This is what we do. And our hope is that we can help you long after the event. We're not a trade show company. We're a networking organization. So if you come to BlueTech Week, it's not like going to a trade show. We want to thank our sponsors, in particular BlueTech Cluster Alliance, the Brink, which is the leading accelerator in San Diego. And if anybody would like to be a sponsor, we'd love to talk to you as well. So with that, I'm going to thank all three of the companies that presented today. Great presentations, incredible progress between Tuesday and Thursday. My own board member, Oriana, you're a rock star, and we really appreciate it. Haro and Water Alliance, thank you. And Tamara, great work for putting this together and for what you're doing with the water wastewater side for us. Thank you all very much. We look forward to seeing you again soon.
Thank you very much as well.
Thank you, everybody.
Bye-bye.
Bye-bye.
Goodbye.
Bye.